Hi, Math. I'd like to go over some of the problems from exercise 6.3 with you. Specifically, I'm going to go over D and then C, F, and I. Hopefully this will clarify a lot of questions that you guys had on NEO. So start off fairly simple with 1D. You're asked to factorize. And when you're asked to factorize, that means you essentially need to create multiplication. And you're creating multiplication from a situation where there's addition or subtraction of two terms or more terms, two or more terms. Like for example, this one is three terms. Well, how do you do that? Well, step one, you have to identify things that both of the terms have in common, right? So 35 and 25t. Well, they don't both have a t, so that's not something they have in common. But 35 and 25 are both multiples of 5, so they have a 5 in common. Is there any higher multiple than 5? Try 10, try other numbers, but actually 5 is the highest common factor of 35 and 25. So 5 is the only number that can be written out front. Sometimes there's a variable. You'll see that later on. Okay, so 5, and then on the inside is just what's left over. So for example, you took out a factor of 5 from the number 35. So what would be left over? Remember, factor is something that you multiply to get another number, right? So I took out the 5 component of 35. So 5 times what is 35? What's left over to get 35 when you multiply? Well, 5 times 7 is 35. And the same thing goes over here. It's the same question. You have a positive 25t. Well, you took out a factor of 5 from that 25, so what's left over? What do you multiply 5 by to get 25? And the answer is just by coincidence another 5. And of course, this 25 had a t, so you write the t as well. Okay? So this is fully factorized. You've made multiplication. How do you know you've made multiplication? Well, you see a 5 next to brackets, and so whenever you see a number next to a bracket, that indicates multiplication. You can check your work. I don't think the directions indicated that you needed to, but you can always check your work. You should be able to expand these brackets and get back to where you started. So I'm going to do that for this one. So 5 times 7 is 35. 5 times positive 5, t, is positive. 5 times 5 is 25, t. Is this the same as that? Yeah, sure it is. So that's how you know you did the things right. This is the answer though, so don't forget, you need to circle and identify your answers. Okay, next up, 33p and 22. 33 and 22. What is the highest common factor of 33 and 22? Well, that's 11. 11 times 3 is 33. So to get to 33p, you have to multiply 11 by 3p. And then 11 times what is 22? Well, that's a 2. And the value that you put between these is simply the sign that you see here. Or more specifically, what you have to multiply 11 by to get that sign. So if this was like a negative 11, I'm not just hypothetically saying this is a negative 11 out front, then this would have to be a negative 2. Because negative times negative would be positive 22. That's not what we had. Let me erase that. What we have is a positive 11, so a positive 11 times positive 2 would make positive 22. Okay, L. 2p plus 4q plus 6r. 2p, 4q, 6r. PQR. Well, there's nothing in common with the variables. In fact, there hasn't been for this first section anything in common with any of the variables. So we can't take out any variables. We will soon down below, but not here. But they all have at least a 2 in common. And it has to be all 3. So for example, if this 2 here was like a 3 or a 5 or something that didn't have a 2 as a factor, then there would be no common factor amongst anything. And your answer in that case would just be prime or not factorable. You could write that out. But since all three of these terms have a 2 in common, a 2 can be brought out front. So it's 2, and then you have, well, what's left over? 2 times what is 2p? Well, 2 times 1 is 2, and then you have p. So 1p. You can just write p. That's fine. You don't have to write 1p. It's understood that 1 times anything is itself. That's fine. 2 times what is 4q? Well, that's a positive 2q. 2 times what is 6r? That's a positive 3r. And you factorized. Okay, let's bump it up here. A little bit more difficult. 3c now, so I'm on number 3. I noticed actually that there's a big jump from number 1 to number 3. So looking here, let me zoom in a little bit. I tried to fix the focus thing, but sometimes it's still out of focus. What we have here is m cubed n squared plus 6m squared n squared times 8m plus n. So there's quite a bit going on. You may be tempted to think of 8m plus n as like a separate term from these other two. So maybe you're thinking, oh, okay, there's 1, 2, 3 different terms. But you really must understand that terms are separated by addition or subtraction. So there's 3 terms here because they're all separated by, in this case, addition. It could have been subtraction or a combination of them. So as it's written right now, there are 2 terms, this one and this one. And it's a mess because you can't just factor out. I mean, how would you do that? So you can kind of see there's an m here and an m there, so you can factor out an m, but there's also an m here, right? So does that mean that goes away as well? And the answer is a definite no. So let me just make that mistake. Just to be clear, maybe some of you are thinking, okay, well, I got an m, I got an m, I got an m. So let's do this. And let's forget about the n's. Let's just factor out an m. So you would have something like this left over, m squared n squared plus 6m n squared. And then how would, it's getting weird because now you're doing this 8 plus n, and then you close everything. I think I'm willing to bet that a few of you did this. And that's a mistake because it's as if you, so like here, when you see m squared, because you're multiplying this group by this group, you're actually not seeing an m squared here. This is going to be an m cubed. And so you can kind of see the problem then. If that was an m cubed and I took out an m, I should have an m squared down here. But it's just m. So it's like you took too many m's out of this particular expression. I'm going to undo my mistake, and we need to think about what our first step really should be, because your first step in this problem cannot be factorized because the problem itself is not separated by all of its terms. So actually, the first step in this problem should be to distribute, to expand these brackets. And I think this may be an aha moment for a few of you. The left stays the same, this term here, so it's still going to be m cubed n squared plus all of this. So the stuff on the outside gets multiplied by the stuff on the inside. So we have 6 times 8, which is 48. M squared times m is m cubed, and then n squared. So that's how you'd write it. So 6m squared n squared times 8m is 48 m cubed n squared. Okay, now it's time to multiply this by the n. Okay, so 6m squared n squared. There's only one thing that combines with the n. It's the n squared. So n squared times n is n cubed. My result then is 6 times, positive times positive is still positive, and then 6m squared n cubed. Do you see how that became m cubed here? That's what I was trying to point out earlier. Okay, now, how many terms are there? Can you see? Yeah, there's three. 1, 2, 3 terms, right? So there's three terms, and so in order to factorize this, we have to identify a common factor with all three of these terms. Okay, I know 6 can go into 48. You see a 48 here, so maybe you can take out a 6, but you can't because there's no factor of 48 with this term. Okay, what do all three terms have in common? Well, they have an m, this one has an m cubed, this one has an m cubed, and this one has an m squared. So the highest power of m that all three of them have in common is not 3, it's actually 2. It's the highest power that they have in common, not the highest power amongst all three. It's the highest one they have in common. So m squared is the highest common factor of those three terms. And looking here at the n's, we have an n squared, we have an n squared, and then we have an n cubed. So the highest common factor amongst the n's is a 2. So this is what you're bringing out in front of the brackets. And then on the inside, what's left over? Well, we have m squared times n squared. What do you have to multiply m squared times n squared to get m cubed n squared? Well, n squared doesn't have to multiply by anything. It's going to be n squared as a result. But how do you do this? Like, what do you multiply m squared by to increase its power by 1? Do you remember? I anticipated this question. And so this goes back to when we were all together still. So it's been a while. But this is section 2.4 in your book. Okay? And section 2.4 and section 2.5 are pretty important to this lesson. If you didn't understand problems like, oh, I don't know, 2b, 5x times 2x times 3y, or look at 2q, right? 9x times 2xy times 3x squared. If you didn't understand that if you multiply the bases, you add the exponents here, you're getting a ripple down, a snowball effect here. That's why math relies so much on previous lessons. And that's why I harp on you guys about, if you don't know how to do something, it should bug you a lot because it's going to come back and get you later on. Anyway, so that's the case here. I want to multiply this m squared n squared by m to get m cubed n squared. And then here we go. So we have m squared times n squared times what gives me 48 m cubed n squared. Well, everything kind of looks the same on this end as the previous problem, but the 48's there. So what do you have to do to get the 48? You just multiply this by 48. It's a positive 48 because there's a plus sign there. So I need to multiply it by a positive 48. So m squared times n squared times 48 will give me 48 m squared n squared, but I want m cubed n squared. So I have to do 48m to multiply it by 48m. And lastly over here, m squared n squared times what gives me m squared n cubed? Well, times what gives me 6m squared n cubed? Well, just like with the 48, it has to be a 6. And then m squared times 6 will be 6m squared, so I'm okay there. But I have the n squared here times what gives me n cubed? That will be an n. Tricky, tricky, tricky. I think we should expand these brackets. So I'm going to check my work. So m squared n squared times m. Well, when I multiply m squared times m, I get m cubed. And then I have the n squared as well. M squared n squared times 48m is a positive 48. M cubed n squared. M squared n squared times 6n, that's a positive 6. M squared n squared times n is n cubed. Does this match the previous step? And the answer is yes, it does. Okay? Let's move on to the next one. What's going on here? This f is actually kind of a big deal. You don't know it yet, but this is how you're going to factorize some quadratic equations, and you don't come across that until, chapter 14 or 15. I can't remember exactly in the book which one it is. I want to put a side example here. What if it was 3x plus 5x? Or in fact, let's not use the same variable. Let me just use b's or something. So I'm gonna pick b. Would you guys be okay with factorizing 3b plus 5b? Yeah, right? I mean, they both have a b in common. The 3 is being multiplied by the same thing that the 5 is, right? And so that can be brought out front. So your result would be b times 3 plus 5, right? This is my side example. So you're not confused. This is a side example. You get b times 3 plus 5. Of course, these were like terms, I suppose, and these could be combined. And so you would have you wouldn't have to factorize it like this. You could have just done 3 plus 5 be 8, and you'd have an 8b. But if I was asking you to factorize, then you would have something like this. Okay? Over here, it's actually pretty similar, except you do have a 3 being multiplied by the same thing the 5 is. So I guess you could just add 3 and 5 together and get 8 times x minus 4. That's possible. I want to take this in a different route because I think it's important to understand it the other way around, kind of like what I was trying to show here, because you're going to have to factorize like this later on. So 3 is being multiplied by the same thing the 5 is. Well, what happened with our side example? The b was brought out in front, and then we had what was left over on the inside, right? Well, in this particular case, the quote-unquote b is actually an expression x minus 4. And so x minus 4, zoom in, x minus 4 can be brought out in front of the 3 and the 5. Did that sink in? That's why I have that side example there. See? These were brought out front because the 3 and the 5 are being multiplied by the same thing. So the x minus 4s are going to be brought out front because the 3 and the 5 are multiplied by the same thing here. And so you have left over, well, x minus 4 times what gives you 3? Well, it's just 3. And then x minus 4 times what gives you a positive 5? It's just a positive 5. So we're not quite done. In this particular case, we have problems that can be combined. We have these two numbers can be combined. So this problem gets a little weird because you have something like that. It makes me want to check the book to make sure that it was, for example, a 3 and a 5 and not like a 5x or a 5z or something. Checking. 6.3. No, that's exactly how it was. So this is okay. You typically put the 8 out front. I would be okay with you guys having this as your answer. You could put 8 out front and have 8x, 8 times x minus 4. That's also okay. Either one of those is fine. I'm kind of curious how the back of the book wanted you to write it. I don't think they would want you to keep this as your answer. That's not simplified all the way. So I'd say one of these two would be the correct answer. Try to avoid this black shadowy bar. 7x cubed y minus 14x squared y squared plus 21xy squared. Okay, this is actually one of those problems where you don't have to expand anything like we did up here. Some of you actually, before I go on to I, Some of you may have been wondering, Mr. Anderson, you just told us to expand. Why didn't we have to do it here? I think that's a pretty good observation there from you guys if you had that. Like, how do you know when to expand and when not to? In the case that I took, I just saw it's so clear to me because there's so many problems that are like this in the future that for you guys as well, that I just like identified, oh, okay, this is combining like terms, like we're factor by grouping, and this did not look familiar to me, so that's why I realized that I should have distributed. So what if you guys distributed here? What if you just did that? I think that's a pretty I think it's actually something that I should talk about. Let me get another piece of paper. And let me just work that problem out with that in mind. So let's just expand out. So we have 3 times x minus 4, so that's 3x minus 12, and then 5 times x, so it's a positive 5x minus 20. Okay, so it's weird because now we have like terms. We have a 3x and a 5x, that makes 8x, and then we have a negative 12, and we have a negative 20. So negative 12 take away 20. Be careful with combining these, right? With adding integers. You're at negative 12, you're taking away 20 more. So you're going further negative. Okay, so your answer is not 8 or negative 8. Negative 12 going further negative. Think of the number line. I'm not going to draw all the digits between, but here's negative 12. If you're at negative 12 and you're subtracting, like you're supposed to be doing here with a minus 20, you're going this way. Well, what's this way? This number, the next number over from negative 12 to the left would be negative 13. It's not negative 11. So you see how you're kind of counting up, right? Have that number line in your head when you're subtracting negatives. You're really kind of adding, in a way, the digits. So this is minus 32. Okay, so now this part of the problem, probably looks fairly similar to problems like this one or that one. We're kind of in the territory now of number 1. So 8x minus 32. What is the biggest thing that they have in common? Well, that's just an 8. And then we have an x minus 4, which is the same thing we got the other method. Okay, now I feel happy about that. I hope you did as well. I hope that was clear. Okay, let's go with I. 7x cubed y minus 14x squared y squared plus 21xy squared. Biggest thing they have in common, 7, 14, 21. So they all have a 7 in common. X cubed, x squared, x. The biggest x that they have in common is x to the first. Y squared, y squared. The biggest y squared they have in common is y. So 7xy times what gives me 7x cubed y? Well, that's just x squared. 7xy times what gives me negative 14 x squared y squared? Well, I have to multiply by negative 2 to get negative 14. 7 times negative 2 is negative 14. X times what is x squared? An x. Y times what is y squared? A y. 7 times what is 21? 7xy times what is 21xy squared? Well, that's a positive 3. Do I put an x here? No. X times x is not x, right? So x times 1 is x, right? So you don't have to write the 1 there. It's not like you have to do 3 times 1 because that's the multiplicative identity. X times 3 is x times 1 is x. So you don't actually have to put that there. Y times what is y squared? That's a y. And you're welcome to check this on your own. Do you have it? Am I convinced as your teacher that you have it? Nope, not really. So guess what? I did 3 here with you guys. I want you to do these 3 now. So your new task is to do B, E, and H. Oh no, he's giving me a fraction problem. Yeah, I am. Okay? Tell you what, pause the video and see if you can do it. Okay? Just understand that there's going to be a quiz on this whenever you guys get back. So, now that you have had time to pause your video, I'm going to go over this. So this is 3B. 17 ABC. These shadows are annoying. Maybe that's the best I can do. Okay, so 17 ABC and then 30 AB squared C. 17 seems kind of primey to me. So I don't think there isn't, right? There is not an HCF of 17 and 30. So we don't have anything there. But we do have some other things in common. We have an A, a B, and a C in common. So the highest A they have in common is an A. The highest B they have in common is a B. And the highest C they have in common is C. What's left over? Well, ABC times what is 17 ABC? Well, it's just 17. ABC times what is 30 AB squared C? Well, it's 30B. Okay? You should be getting 100% on these because you can always distribute back out and check your work. Here we go. 3/4 x to the 4th times, plus 7/8 x. Is there anything in common with 3/4 and 7/8? Maybe if you had a common denominator, you could tell. I'm thinking also, do we really need to have a common factor brought out? Well, we could rewrite the problem as, instead of 3/4, we could write it as 6/8. Do you see how that's the equivalent fraction? 3/4 and 6/8. X to the 4th plus 7/8 x. Okay. So it looks like they're both being divided by 8, right? So there is a common factor, at least that we can come up with. Okay, if they have a common divisor, is that the same thing as a common, like you're multiplying here and then you're dividing by 8 here? Do you just put the divided by 8 kind of underneath the brackets? Like as if that was like divided by 8 here or something? No, not really. You guys have to understand the relationship between multiplication and division. Division can be written as multiplication. Let me show you. 1/8 times is the same thing as that thing divided by 8. Okay, so it's actually okay to put a 1/8 out front. So I'm going to do that, 1/8. And what else do they have in common here? They both have, that's a 6 and a 7, that doesn't work, but x does work. There's an x that both of these have in common. So inside the bracket, what's left over? Well, 1/8 x times what? Let's just forget about the x for now. 1/8 times what is 6/8? It's 6. X times what is x to the 4th? X cubed. Okay. 1/8 times what is 7/8? Well, that's 7. It's a positive 7/8, so it's a positive 7. X times what is x? It's just 1, so I don't have to write 7 times 1 here. 7 times 1 is 7. All right. Maybe this one would be a good one to check. So 1/8 x times 6x cubed, that would be 6/8. X times x cubed is x to the 4th. 1/8 x times 7 is positive 7/8 x. Let's just make sure we get back to the original, right? Well, 6/8, they both can be divided by 2. And that would be 3/4 x to the 4th plus, this doesn't reduce at all, 7/8 x. So that worked out. We were able to, oh, sorry about that. There we go. That reduced. That's the only thing that I did really from this step to this step. And so that 6/8 reduced to 3/4. And so that checked out. Okay, so we can be very confident then that this is our answer. Okay, again, like I said, you should be getting 100% here. Okay, so next up, 6x cubed plus 2x to the 4th plus 4x to the 5th. Okay, they all have a 2. The highest common factor that they have is a 2, right? And then with the x's, this is kind of the first time, like before we just had x to the first, right? This is just an x, a first, a, b, c, and then on the other ones, first power. We've always ever only brought out the first power, right? Because that's the biggest thing that they had in common. Between x to the 4th and x, well, they had the highest thing they have is an x. Now here, this is the first time that you're seeing a problem where the biggest power of x is not 1, it's actually what? 3. So you can bring out an x cubed. So 2x cubed times what is 6x cubed? 2 times what is 6? It's 2 times 3 is 6. And then x cubed times 1 is x cubed. You don't have to write anything there. 2 times what is 2? Well, that's just 1. X cubed times what is x to the 4th? That would be x, and it's a positive x. 2x cubed times what is 4x to the 5th? Well, 2 times 2 is 4. X cubed times x squared would be x to the 5th. All right? This situation here kind of made me want to come up with a side example. So I'm going to just put a problem Z on here. 6x cubed plus 2x plus 2x cubed plus 4x to the 5th. Will that make it, would that be in? I want to make this a 6x to the 4th so that these are not like terms, and then we could have just combined them. So here's my side example. This is example Z, and I do want you guys to copy along with me. In fact, pause the video and try to factorize. Okay. So 6x to the 4th, 2x cubed, 4x to the 5th, they all have a 2, just like before, in common. They all have an x cubed, just like before, in common. So what we have here, we have 3, 2 times 3 is 6, x, just x now. So x cubed times x would be x to the 4th. And then here, what did you guys do here? Did you just ignore it and go on to the next? Like, how do you write that? 2x cubed times what is 2x cubed? Well, it's a 1, and you actually have to show that. So it's a positive 1. If you thought ahead and you know, if you thought about how you're checking these problems, you have to think about, okay, when I multiply these brackets out, I have to have something there because there's 3 terms. And so if you just kind of glossed over that plus 1 and went over to the 4x to the 5th, and you made it, it would have been a 2x squared, and then, you know, that all of a sudden is 2 terms inside those parentheses, right? And if you were to expand these brackets out, you wouldn't have the same result as when you started. So that's kind of why you have to think, you know, about checking your problems like as you're working through them, and realize, oh, I need to have a 1 as a placeholder here. 2x cubed times 1 is 2x cubed. Okay, and then 2x cubed times 2x squared made 2x to the 5th. And there's your answer. I hope this helped. I actually kind of enjoy doing this, so if you guys want more of this, just keep on asking questions and I can work out problems. Hope you guys have a great term break and the rest of your week.